Hello mathematicians, I hope by the end of this video you can say I can determine the percent error. In this video we're going to look at a word problem and we're going to derive our formula which we're going to use to solve percent error problems in the future. So it says Sadie measured a line to be 13.9 inches long. If the actual length of the line is 16.2 inches, then what was the percent error of the measurement to the nearest tenth of a percent? So the formula for percent error is might use different words depending on what the word problem is. In this situation, when they're measuring the distance of a line, our formula for percent error is going to be the difference between the measured length and the actual length. So it's measured minus actual, and it's the difference between the two. So it's actually going to be the absolute value of the measured minus the actual length. And we're going to find the percent error by taking this difference between the measured and the actual length, and we're going to divide it by the actual length. So the percent error is the ratio between the difference of the measured minus the actual to the actual, and it's that ratio. And to make it a percentage rather than just a decimal, we're going to multiply it by 100. So using this absolute value of the measured, which was 13.9 inches, we're going to subtract the actual length, which was 16.2 inches. And remember, that is the absolute value of those. And the percent error is the ratio between this distance and the actual length, which is 16.2 inches. And we're going to take that and we're going to multiply that by 100. So to find this difference, so it's 13.9 minus 16.2. So what we can do is we can actually just go 16.2 minus 13.9, and because it's absolute value, it really doesn't matter. We're just trying to find out what the difference is. So let's keep the bigger number on top. 2 minus 9, can't do that, need to borrow. 12 minus 9 is 3, bring the decimal straight down. 5 minus 3 is 2. 1 minus 1 is 0, so that's it. So we get the absolute value of 2.3, or it would be negative 2.3, but the absolute value is positive 2.3 over 16.2 times 100, and 2.3 divided by 16.2 is 0.142, and multiply that by 100, and we get 14.2%, and that is what our percent error is. So that's it for a video. I hope after watching this and getting in a little bit of practice, you can say I can determine the percent error.